Hello technicians and welcome to the Life Safety Troubleshooter. My name is Gary and first I'd like to tell you a little bit about myself. I am a U.S. Navy veteran and I served as an aviation electrician's mate 3rd class working on aircraft. I've been in the life safety industry now for 47 years. The first 41 years of my career I spent as a service technician, installer, manager, and alarm dispatcher. The last 5 years plus I've spent as a senior help desk specialist, assisting technicians in the field, salespeople, and customers. So in that career that I've had, I've learned quite a few different ways to find ground faults. Yes, I said it, ground faults, the dreaded ground faults. So I'm going to show you a way to do this, but first I'd like to explain you why my way is superior to what you may use with an ohm meter. So what I want to show you is basically, here's my meter, and here's this little black box. Well, this little black box is a 24 volt, power limited to 100 milliamp power supply. And you'll notice that the negative of this battery is sitting on the negative of the meter. The positive of the battery is going over to a test tank right here to this wire, which is going down and it's underneath the water. The positive of the meter is sitting on what would be your cable. It's going in here and you'll notice that there's a rope there and it's sitting in water. So, this is how you use this. With this set up here, and I'm going to go ahead and show you the meter while I do this. You'll notice that the meter's reading about 201 microamps. So, as the cable, and think of this rope as a cable, as the cable gets wet inside the conduit, notice how the reading jumps up. Now, you'll notice as it starts to dry out, the current draw goes down. You'll also notice that as I pull it out of the water, I'm going to pull it out slowly. You see how the reading drops and drops and drops until finally it goes away. Now, think of this, like I said, as a conduit full of water. And of course it fills with water when it rains, and then when it stops raining it may leak back out into the ground and somewhat dry out. So now it's going to rain again and the conduit's going to fill with water and it's going to cover this wire, and it's going to be even worse if this wire is damaged. If it's got an abraded point that's showing bare copper, it's going to be worse. So this is how you can find these grounds in wet conduits. And believe me, it doesn't necessarily have to be a damaged wire, because I have pulled fire cable out of conduit that has literally been pink. Remember, many of the systems out there have been out there for years. Panels may change, wiring does not. And if that wiring stays in that water-filled conduit long enough, and it's a fire cable, it will actually leach pink. And when you pull the wire out, the water will have actually seeped through the insulation and inside of that jacket. So yes, you can have bad cabling in conduit that'll cause this problem. So this is a good way to find that. Now, what I want to do is I want to tell you a couple instances where I have found ground faults. First instance is, in both of these instances, other technicians had already been there. Couldn't find the problem. And there's nothing worse than telling a customer, I'm sorry, the ground's gone, the problem's gone, when it comes back, call me. So I go out there with this Cobb Boxx, is what I call it, power supply, and my meter, and I read, and I find that I'm reading on a module that I'm reading about 30 to 40 microamps going out to a PIV. PIV, for those of you who don't know, is a post indicator valve. So post indicator valve is nothing more than a metal rod, metal little tube coming out of the ground about 4 to 6 inches in diameter. And it has a gate valve switch attached to it. So now you got metal tube, metal switch, metal cover. Not hard to figure out how easy it is for that to produce a ground. So I go outside and I inspect it. And I have a plastic conduit coming up to a box, and out of that box I have a piece of seal tight, which is basically flexible plastic conduit, so to speak, going up to the switch. Switch is still the metal switch. I noticed that at the bottom of this seal tight, it's damaged, got a little crack in it, and upon closer inspection, I've got ants going in and out of this crack. I thought, okay, not hard to figure out what's going on here, but let's go ahead and pull the cover off and find out for sure. I pull the cover off, and there's 1,000,000 ants with 1,000,000 eggs going to town inside this switch. Well, obviously, that was my ground fault, so I cleaned out the ants, taped up the wire, pulled off the seal tight, put a new piece of seal tight in, sealed everything back up, ground is gone. So that's one instance. Now, in relation to this tank, and pretending that this is the cable and it's underwater in conduit, another instance, and again, I was not the first one there. I go to the job site and I start reading it because its panel was showing intermittent ground. Of course, when I got there 2 days later, it wasn't there. So I go ahead and I meter it, and I see a ground pulling 30 to 40 microamps. I said, okay, that's not enough to put it in the ground, but it's enough to trace. So I go after this ground, and I trace it to an X circuit, and I trace it into the church to a 100-foot wall. It has 3 horn strobes on it. So I read between the first and the second, and I'm reading ground. I read between the second and the third, and I'm reading ground. So now I got about a total of 100 feet minus the up wires. Say we'll call it 75 feet. So I've got 75 feet of cable in this conduit showing me a ground. And this was after it rained like 2 days ago. So I call out installers, and they were very skeptical about this and weren't really too willing to replace this cable. But I insisted, and they start replacing the cable. And of course, one more wire, 80% is supposed to be the fill, but one more wire. So the wire was pretty tight, and we had to pull it out and replace it with direct burial cable because it's not affected so much by being in water. So we start pulling it out. Wire is pink because it had been in water for about 15 years. It's about how old this building was. So we start pulling it out. Wire's wet, muddy, just totally nasty. Pull it all out, pull new cable through. Never went back again for an intermittent ground. So you will find these grounds that are intermittent in this way by searching for the current draw in microamps. You will find these cables underneath ground going to PIVs. You will find these cables on outside walls where the conduit goes down and pretty much the water is seeping into the conduit, and apparently the conduit's broken because when we pulled this wire out of there, it was muddy. So another thing that you can use in order to find a ground fault, and let me show you my little drawing here. And I'm sure you've run into this before. My record for finding a ground lies within here, and it's 5 minutes it took me to find a ground. Now, you take your Cobb Boxx and you take the positive lead to ground. You take the negative lead over to the negative meter, and you take the positive lead to the meter, and you read dry circuit Of course, you always want to read a dry circuit, and you read either side. Now, when I read either side of a SLC and I see, and this is approximate, it'll vary, say 20 to 25 milliamps on one side and 25 to 30 milliamps on the other side, and not the full 95 to 100 milliamps that you'll see on a short from this box, then I know it's a module. And this is why I know it's a module. Number one, control module. Usually a short, very short circuit going into an RPS, and the module may even be in the RPS. Smoke detectors, they have no external circuit. So that's a no right there. A pull station. Most of them these days are plastic, and it's a very short circuit in there. They got many modules in there that work that pull station. However, now we get to a double module and a single module, initiating circuits. They go out in the field with Class B circuits. So you'll notice I've got this circled, and this had a ground fault on this Class B circuit on this initiating module. So this is the reading you're going to see when it's an initiating module in the field that's grounded. Now, what this does for you is it allows you to eliminate a lot of times anywhere from 80 to 90% of your circuit. You know it's going to be on a module. Now, on most big buildings, you have a sprinkler system. So if you got a sprinkler system is metal pipes, metal switches. You could go in there and say, okay, I'm looking for a ground. It may be a 12,000 square foot building, but I know it's in the sprinkler room, or I'm fairly sure it's in the sprinkler room because I know it's on a module. So I put my special tester on this, and we'll get into my special tester later, but it basically allows you to troubleshoot without a meter using an audible signal to tell you if the circuit opens, shorts, or intermittently opens or shorts at about 100 milliseconds. So I put my special tester on that, and I go out and I do what's called shaking the circuit down. I go in the sprinkler room, I take my screwdriver, and I start tapping on devices, pulling on greenfield. I go in there and I get to the dry system. Now, of course, dry system has a compressor. Compressor vibrates. We live with vibration every day. We just don't notice it because we've become accustomed to it. So we don't even think about it. Of course, wiring is susceptible to vibration. So I tap on the tamper switch, gate valve switch, starts beeping at me. I said, okay, it's either on, in, or near this gate valve switch. So I proceed to take the cover off. Immediately, the ground fault goes away. Solid beep from the tester, telling me that the circuit is now opened and is no longer grounded. So on closer inspection, I find that it had a resistor that someone was not neat, and believe me, it pays to be neat when you're working on a job. Be neat when you do this wiring, because somebody wasn't neat with this wiring, with this resistor, because when they threw it on this switch, they just let it sit up in the air. So when they put the cover back on, the resistor was rubbing against the inside of the cover. Well, vibration over a period of time had finally wore through the paint on this resistor down to the carbon. And the carbon of the resistor was actually grounding out the circuit. So all I needed to do was go ahead and tape that resistor, tuck it in neatly, put the cover back on. 5 minutes, I was done. Took me longer to fill out the ticket for the job. So that's another way you can use this box. Now, let me tell you about the time that I found a ground fault in a 50,000 seat stadium in about an hour and 15 minutes. And the way I did that, I'm going to show you here real quick, is what I did is I was reading current as I normally use. And what I was seeing was it was just floating all over the place, just going nuts. Now, you can see it a lot better with an analog meter that's got the needle on it rather than the digital meter. But here's a way around that. Get yourself a piezo, Sonalert, a beeper. Put it in series with this. So now you've got the Cobb Boxx, the meter, the Sonalert, all in series. This polarity sensitive. And I'm going to show you real quick here with a wire on the box here, and I want you to listen carefully, because if this grounds, you can hear it vibrating and going off. And that's what you're going to hear if you've got a vibration ground out there in the field. So, having said that, this is what I found, and this is how I found it. Now, most HVAC units you can turn off individually, most of the time through a computer these days, because you have very advanced HVAC systems. So I asked the technician there, the maintenance guy, I said, hey, can you start turning off some of these HVAC units? Because HVAC units are notorious for causing the vibration that wears in the wire. I at one point found a damaged wire because they had run a metal greenfield to a furnace, run the normal, very thin fire cable, and it actually vibrated enough when I pulled that wire out of that greenfield, you could see every single spot where the rings of the greenfield wore in to the fire cable. So anyway, I had him turn off and on several HVAC units until he got to one particular one, and the beeping stopped. Now, it's going to do one of two things. It's either going to stop or it's going to go solid. Depends on how it feels that day. So it stopped. I went, okay, turn it back on, start hearing the crackle again. Not quite as bad, but still heard the crackle. I said, okay, where's that HVAC unit at? He says, well, that's the HVAC unit down there at the concession stand on the 3rd level. So we go down there, and as you can see by this drawing here, had about an 18-foot ceiling with an 8-foot suspended ceiling, and they had a smoke detector sitting on that suspended ceiling. Well, what they did is they brought the fire cable down without doing a 90. They just let it loop right down, and sure as can be, they allowed it to lay on the edge of a duct. And that duct was vibrating from the main unit running. So it had actually wore through the insulation down to the copper, and that's where my intermittent ground fault was at. So I taped it, fixed it, put it back up, problem solved. And that was in a 50,000 seat stadium, which you can just imagine if you've been in stadiums watching football games, baseball games. Pretty big stadium, 50,000 capacity. So that's another way you can find a ground with this, using a simple Sonalert piezo. In the old days we used to call them Sonalerts. They're piezos. They're the little beepy things. So that's not the only thing this will do. This will also find the dreaded invalid replies with no set pattern. Now, a lot of you are going to know exactly what I'm talking about, because you've had customers say, well, my panel is going into trouble and it does it intermittently and I have no idea why. And you go and check the history and it's an addressable panel, and you can see things going invalid, missing, no answer, whatever the panel make is, it varies what they call it when a module or a detector goes offline. I have a way to find that we have found many of these modules in the field as of late. I don't know why they fail. I just know all of a sudden these modules, and it's mostly going to be relays, and it's going to be single and dual modules. Sometimes it's a control module. I've yet to see a mini module or smoke detectors do this, but what happens is it decides, I am no longer happy with 140 to 200 microamps of power. I want more. And out of the blue, this thing will start sucking power. 1 mil, 2 mil, 10, 20, 50, 100 mils. And it crashes your SLC circuit. Well, I have a way that you can find those with this setup using this Cobb Boxx. I will go through that in the future. I'll also go through the special tester of mine once I get it patented, which allows you to troubleshoot without having to use a meter most of the time. Not all the time, but most of the time. And it's particularly great at finding intermittent shorts in intermittent grounds, which technically are kind of both the same thing. You just happen to be shorting to ground instead of shorting to two wires, or sometimes even shorting to another circuit. I've had that, which causes an intermittent ground, especially if it happens to short to an RPS, because now you've got a ground fault circuit leaking into another ground fault circuit and causing that circular circuit, and both of them sometimes go into ground. So if you're interested in what I have here and what I'm trying to teach in using this method, please like, share, and subscribe. I'm going to make more of these videos, and I'm hoping to get my special tester out there soon after it gets patented. But there's so much I can teach with this particular box and some of the methods I use, which I think will be quite beneficial to technicians to do their job more efficiently and keep those customers happy instead of having to tell them, when it comes back, let us know. So again, like, share, subscribe, and I will be making more videos for this. Thank you for your time. I hope you enjoyed the video.